Hi guys, I'm Jess Lane, and if you are watching, these are continuing of talking about radicals. We're going to talk about how to multiply radicals. So it doesn't have to do with addition and subtraction. You do not have to have the same number under the radical like you do in addition and subtraction. What you do need to know is that when you're multiplying radicals, you multiply the numbers underneath the radicals just like normal. So like if you have square root of 5 times square root of 35, you do 5 times 35, which is 175. That's still all under the square root symbol, still under the radical. So we have square root of 175. And then you apply what you learned in the simplifying radicals video to this. So we're going to do the prime factorization of 175. I know that 5 goes into it because 175 ends in 5. And so 175, I think it's 35, I'm pretty sure. But I am going to check my math. Yeah, 35. So 5 times 35, and then I'm going to continue to go. And so the prime factorization of 175 is 5 times 5 times 7. And remember, I'm looking for the pairs, so I can take out a 5. So square root of 175 will simplify to 5 square root of 7. 5 square root of 7. Very good. Okay, let's continue to do some more of these. Okay, 2 square root of 8 times 3 square root of 7. So when you have numbers outside of the radicals, what you do is you do the number multiplied by the number outside the radicals, and then the numbers underneath the radicals you multiply as well. So in this case, 2 times 3, because these are the numbers outside the radicals, is 6. And then we have our radical, and we do 8 times 7, which is 56. And then we want to simplify that radical, 6 square root of 56. We simplify it. So I'm going to do a prime factorization tree for the number under the radical, which is 56. And I am going to notice that it's 2 times 2 times 2 times 7 is the prime factorization of 56. I can take out a 2, left with 2 and a 7 still under the radical. So 2 times 7 is 14. So I'm still left with the radical of 14. But I can take out a 2. But since I can take out a 2 and there's already a 6 there, I multiply them together. 6 times 2 is 12. So that is the simplified version of 6 square root of 56 becomes 12 square root of 14. So that is how you multiply radicals. Now let's talk about division. How to divide radicals is the same thing. You will, so if you have square root of 56 divided by square root of 7, all you do is you just, if they're under the radicals, then you just divide them. 56 divided by 7 is 8. So in this case, we have the square root of 8 is our answer. But you can actually simplify square root of 8, okay? So 8 is 2 times 2 times 2 in prime factorization. I can take out a pair of 2's with a 2 left under. So this would become 2 square root of 2. If you don't know how to simplify radicals, make sure you go and watch that video, okay? 2 square root of 2. Okay, another example. Square root of 6 divided by square root of 7. In this case, you can't divide 6 divided by 7. It's not a whole number. So you're going to have to do this a little differently. You cannot have a radical on the bottom. So to get rid of the radical on the bottom, you multiply it by itself. So I'm going to multiply it by the square root of 7. But what I do to one, I have to do to the other because I have to continue to make this fraction equal. So I can't just change the bottom and not change the top. So, whoops, this should be 7. So I'm multiplying this by square root of 7, so I'm multiplying the top by square root of 7. And the reason why is because now we're going to multiply them, and we'll simplify because we know how to multiply radicals. We just multiply the numbers that are underneath. 6 times 7 is 42. So that's square root of 42. And then 7 times 7 is 49. So square root of 49. I can simplify this anymore because I see that I have a perfect square. Square root of 49 is 7. So square root of 42 all over 7. Okay? So let's talk about this. Anytime you multiply a radical by itself, you just basically take that number out of the radical, because that's how it will do, because 7 times 7 is 49, square root of 49 is 7. You notice it's just that number out of the radical. So to take anything out of a radical, you can just multiply it by itself to take it out of the radical. So we have square root of 42 over 7. I don't think the prime factorization of 42 has anything that we can take out. Nope, because the prime factorization of 42 is 2 times 3 times 7. And so there's nothing we can take out. So this is simplified. The square root of 42 over 7. We cannot leave it like this, although you can't divide 6 and 7. We can never have a radical in our answer when it's simplified, or in our denominator when it's simplified. So we'll simplify to that. Okay, let's do another example. 3 divided by the square root of 12. Now, although 3 and 12 will reduce, we cannot combine these because one's outside the radical, one's inside the radical. So we need to simplify this by taking 12 out of the radical, because we can't have a radical in our denominator. Remember how we do that? We just did it in our example before. We're going to multiply both the numerator and the denominator by the square root of 12. When we do that, I'm going to take the shortcut now. When we multiply a radical by itself, we know that number just simply comes out. So it's just simply 12. And then 3 times the square root of 12 is just 3 square root of 12, right? Because we multiply the number outside the radical by the number outside the radical. This is understood as 1. If it's outside, 3 times 1 is 3, and then there's no radicals to combine. We just bring the square root of 12 over. Now we have 3 square root of 12 all over 12. Now we have 3 and 12. They're both outside the radical, so we can simplify them like a fraction. 3, we can reduce this down to 3 divided by 3 is 1, 12 divided by 3 is 4. So 1 square root of 12 over 4 is how we reduce that. Technically, we don't even need that 1, so we can erase it. So it can just be square root of 12 over 4, because that 1's understood. That is how you multiply and divide radicals. Thank you for joining.